Hello, my name is Charles Threlkeld, and I'm here to talk about my work with J.P. de Ruyter at the Human Interaction Lab at Tufts University, entitled "The Duration of a Turn Cannot Be Used to Predict When It Ends." So our research question is, can we use duration as information for when a turn or turn construction unit will end? We might think this is the case because there might be some minimum amount of information to comprise a turn or turn construction unit, and some maximum amount at which point it's normative for a new TCU to take over or for our interlocutor to have a turn. For this research, we collected about 5,800 turns composed of about 12,000 turn construction units taken from the switchboard corpus. We operationalized milliseconds for raw duration, syllables for phonological units, and words for semantic units. For each parameter, we built an exponential model which has the distinction of having a constant hazard rate, which means that no matter how long a turn or TCU has been going on, it has a constant chance to end in the next second. So for example, if I've been speaking 10 seconds or 10 minutes, my chance to finish speaking in the next second is constant. We'll compare this with a gamma distribution, which includes a shape which has an abstraction on the exponential distribution with a shape parameter. So note that the gamma distribution is equivalent to the exponential when the shape parameter is 1 and the rates are equivalent between the two. We'll compare the two using the widely applicable information criterion as our error statistic. So starting with the turn construction unit millisecond duration, we can see that the shape is almost collapsing into an exponential, and we have equivalent error metrics. Next we have the turn construction unit syllable count, where we have a slightly higher shape, but note that the shape is any positive real number, so this is still a very close shape, and equivalent error metrics. You note that our exponential model has difficulty accounting for the very low syllable counts, which is a theme we'll see. For the word counts, this is the highest gamma shape that we'll see, and there's a slight preference in our error statistic for our gamma model, which better accounts for the extremely low word counts that we find in the data compared to the exponential model. Moving on to full turns, we now have gamma shapes that are less than 1, and we can see that this creates a wider, fatter tail in the gamma model, accounting for these high peaks and fast cutoff, but the exponential model is losing out on these low millisecond durations. Slight preference in our error metric for the gamma model. Turn syllable count, we have the lowest gamma shape that we'll see and the highest disparity between the gamma and exponential model, again accounting for these very low turn syllable counts. Same with the word count, with a rather low gamma shape and some preference to the gamma model. Finally, we did turn construction units per turn, where we use the geometric and negative binomial models, which are the discrete versions of the exponential and gamma models. We can see that the n is quite far from 1, which is equivalent to the shape for the gamma model, but our error metric gives significant preference to the simpler geometric model. Here we can see that there is a higher instance of short turns compared to the models that we've built. And in fact, that's what we've seen throughout this discussion, is that there is some preference for extremely short turns and extremely short turn construction units. However, other than that, we can learn very little using duration as information for when a turn or TCU will end. Thank you for your time. I look forward to talking to you about this work.